Okay. Hey, nice to see you all.
Yes. Nice to see you. I
Nice
suggest
to
we wait
see
2 more
you.
minutes. But
Or
Yeah.
I
shall
will
we?
first make an introduction.
Okay.
Sidharth is from India, and he's founder of Medblocks, and he has a vision to revolutionize healthcare IT by making health data platforms the standard foundation for healthcare software development. Sidharth will present openEHR and structural data in the age of generative AI. So Sidharth, please, second chance now.
Yes. Hopefully you can see my screen. You can hear
Yes.
me. All good. Okay. So thanks, Jan. Thank you for that introduction. And the previous presentation, I was just blown away by the amount of momentum we are seeing in Europe on data, the need for quality data and structured data, right? And most of us are in this space. But again, I want to show you this quote. Don't ask a barber if you need a haircut, right? Because we are technically all in the structured data space. So there is this tendency for us to always say that, yes, we need data, we need quality data. Why is there a question about that? But if we think about it, right, like the answer to something cannot be because we've just always done it this way, right? And a lot of what we have with regards to data and what it really means to have quality data boils down to we've done this way, right? Like, so if we take all of the standards that we have today, HL7, V2 to FHIR, openEHR, SNOMED-CT, LOINC, CCDA, my argument here in this particular talk, and I know this might make some of you uncomfortable, but again, it's our responsibility to make sure that we are looking at certain things from another perspective as well as what we have today, right? So my question to you in this talk, and again, please comment on this and you can ask other questions and join this discussion as well. I don't know the answer to this, but this is a thought experiment. Do you need structured data at all in the era of Gen AI? Do we need openEHR? Do we need FHIR? Do we need SNOMED-CT? Do we need LOINC? Do we need ICD-10? Do you need any of these things in the era of Gen AI, of generative AI and of large language models? And again, we are just seeing the start of this new foundational type of computing, and it's only going to get better and better from here. So the GPT-4 or whatever large language model you have today is going to be the worst it's ever going to be in the history of what we've now started off, right? Now, I know most of you have enrolled for the openEHR course and you want openEHR to be used, and it is, again, I have a whole company built on the same, but let's try to answer this. So why do we need structured data, right? So if you think about it, if you take a step back and if we just think about why do we really need structured data for healthcare, it provides us a bunch of different things. So exchange, right? Like you are able to represent the meaning of data in the same way across organizational boundaries. You're able to send this data and other people are able to interpret it in the same sense. You can do validation. You make sure that the data quality is ensured when it's being captured, and you show them errors in case something is not right. You can search your data easily, right? You can find the information you need when you need it. You can get all the relevant results for a particular patient, all the lab tests that are abnormal for a particular patient immediately to make your next clinical decision. And analytics. You can run complex queries on population level data, and you need something structured to run these complex queries, right? Like, so this has been, I think, told to us again and again and again that, okay, to do any of this, you actually need structured data. So you can't do any of this if you don't have structured data. So our assumption is like, okay, so structured data is needed because we need all of this. But think about, again, like just a thought experiment here. So what if today we have large language models that can answer like basic questions on like a bunch of text. Okay. Now think of a large language model or an LLM or a generative AI agent, which has infinite memory and infinite context length. Okay. So what this means is it can answer any question accurately in arbitrarily large data sets. You throw it 1 GB of tabular data in a CSV, it will answer it exactly right without any hallucinations, and it will answer all the questions right. So again, this is completely hypothetical. There is no model today that does this, right? But if there was an LLM that were to do this, if it had infinite memory and if it had infinite context length, do you still need databases? Like, just think about it. You could feed it everything that you need within the context window. You could just say that, okay, I want you to remember XYZ about this patient. Just keep going. The next patient comes, you just keep letting the model store the data, and then you ask for your data back. You just ask for it, give me all this patient's blood pressure readings. It's like, it's a thought experiment, so it's 100% accurate. It gives it to you back. But what's interesting is that you can also ask it to just say, for this patient, can you export all of the data as a FHIR resource? I wanted to export it as a FHIR resource according to this profile. You remember everything about this patient. Why don't you just give me what I want, right? Now, let's take another scenario, right? So can you count the number of patients with rabies? So let's say we have 2 patients. And one patient, you just have like some unstructured text. You have something that's present in the database where you say the patient has been bitten by a dog a week ago. Now the patient complains of excessive salivation and the patient fears water. Okay. Now patient 2, you say diagnosis rabies. Okay. Now, if I ask you, how many patients have rabies? Again, this is an analytical question that we are running on top of this data set that we just are seeing in front of us. Again, like, let me know in the chats, like, how many of you will say there are 2 patients with rabies here? And how many of you will say there are 1 patient with rabies here? Like, just put it in the chat. I just want to like conduct this thought experiment. How many say 1? Just type 1. And if you're saying 2, just type 2 in the chat. So I am okay. That is, yeah, I kind of expected this. So I'm seeing almost an even split between 1 and 2, with a lot more tending towards 1. And I think it's a 60-40 split between 1 and 2, right? So now here's the problem, right? Like, so as a team, or as a group of people, I can just replace this. Like, I can take AI out and I can just say, like, hey person, can you do this? And we have different answers. And I think that's interesting to discuss. So now we can represent meaning in different ways, right? Like, so you have learned representation of meaning. So this is what large language models and like these more advanced AI algorithms use. So they learn the representation of what something means by themselves, and they finally represent it as a bunch of numbers. These are usually vectors in like a high dimensional space, but we'll not go into the details of it. They just learn what something means, and things that mean the same thing together are kind of grouped together in this higher dimensional space. It's hard to visualize, but yeah, these are like usually 400 dimensional vector embeddings or something like that. Now, on the other side, we have handcrafted representation of meaning. So you have things like openEHR, FHIR representing the information model. You have SNOMED-CT, LawInc, ICD-10. You have all of these ontologies representing the meaning of different concepts, right? And we're even seeing SNOMED-CT with post coordination comes very close to representing information modeling itself, right? So if you were to separate this out, again, like there are information models which kind of represent the question, or like, what are we talking about? What is the data model here? And then there are ontologies that talk about like the concepts that go inside these information models. Now it's a very blurry setting because, for example, openEHR has local terminologies and FHIR has local value sets. SNOMED City has post coordination, which can be used as an information model. So there are different nuances here, but in essence, what we are looking at is there is one thing called the information model itself, which describes, okay, what are the different fields that this particular entity can have. And then you have ontologies, which are just like network of different concepts and meanings, right? So now if we go back to the learned representations, in the field of ML and the field of AI, you see a really good amount of representation of ontologies. So words can be represented as vectors, and these go in together, which is a very, very similar representation to what an ontology like SNOMED City does, except that it's handcrafted, right? Whereas an information model, that has, again, I've studied this quite a bit and I've tried to understand, are there any models that represent ontologies of information models? And then to my surprise, nothing yet, right? Nothing represents information models properly yet. And our only way to communicate information models today is through either like a properly defined schema or a model, or through natural language if we have to communicate that to an AI model. So again, let's replace this question. So instead of AI, can you count the number of patients with rabies? Change it to John. Can you count the number of patients with rabies? Now, if we get two different answers, that means that our question and the data is not specific enough, right? And this is the whole problem. Like ambiguity kills. Like the problem here is not that the data points are not computable. They 100% are. You as human beings, you looked at this data set, you looked at the question, and based on the same question and the same data set, you came to different conclusions. Half of you thought it was 2, half of you thought it was 1, right? So the problem now is that ambiguity is the problem here, right? So now let's take a look at what we have learned from other fields and what we can do to apply this to our own, our pattern of thinking, right? So if you take the programming paradigm, like start with the hardware, then you go with bare metal machine language, like just zeros and ones, like compiled binary. Then you have like assembly language, which is a little higher level. Then you have like high level languages. Then you have things like C++, C, Pascal. Then on top of this, you have Python. And then on top of this, again, like we are seeing LLMs directly convert data or like your request into Python, and that interprets it within the Python interpreter. But by running that, it like literally goes down the full pyramid, right? Like you're using literally every part of the pyramid. So now I think it's very similar in health IT. You have these layers of artifacts, right? So you start with the information models. Now, again, the reason why you need the information model is to prevent ambiguity. That's it. So in fact, I actually think, and again, you may have another argument for this. I'm happy to hear that. But I think if you are able to eliminate ambiguity in this question by using natural language, I think you don't need information models. But I also think that what information models do is eliminate ambiguity to begin with. So for example, if you take a look at the CKM on openEHR, or if you take a look at an implementation guide on FHIR, what it actually is a guide or a definition of when a certain data point can be used and in which context, right? So information models in my definition are just like ambiguity killing machines. And some of these standards have done this really well. Like for example, openEHR and the CKM with the number of archetypes, they've done it really well. And there are just like so many really good information models out there. Now ontologies and value sets. So this, in my opinion, is a little bit more ambiguous again, like because you can do the same thing. You can represent the meaning of a particular clinical concept or a particular word as a learned representation, as a vector embedding, as well as an ontology. So in that case, does it still have a place with this new paradigm of computing that we are seeing? And again, I still think it's yes, because if you take a look at this layers of progress, right, it usually tends to be that the top layer uses the bottom layers to really like make sense. So when again, like I think in a very real sense, ontologies and value sets also disambiguate quite a bit. So there are different code systems used for billing. There are different code systems for insurance codes, and ICD is initially started off classifying deaths, and it was there even when we as people needed to define a particular disease well enough. And I see this being used in, for example, psychiatry, right? I see psychiatrists use ICD-10 codes to communicate between psychiatrists. So they have no reason to do this, but they still do this because many of the conditions are very similar that it's hard to disambiguate between them if you're not using an ICD code. So I was taken aback the first time I saw two psychiatrists just talk ICD codes between themselves to define a condition when nothing else was involved. There was no other system, right? So I think in a very real sense, SNOMED and all of these value sets, and all of these ontologies, they define the meaning in a way that humans and machines can start exchanging information without ambiguity, right? And again, it's not just humans and machines, it could just be humans and humans, because we've seen that happen as well. Then on top of this, you have query engines. So query engines are able to like run something on top of this data substrate. Like I think the data substrate here is the information models and the ontologies, and they're able to give you something back, right? Like they're giving you back results. Now, you may ask, yes, do you really need query engines if you have a large language model that has infinite context length and infinite memory? And I think technically the answer is no. If you have the query engines and the rule engines may become obsolete if LLMs become really good. But with what we are seeing today and the state of LLMs and the state of AI today, it's safe to say that it's very expensive to do that, right? Like it's very expensive to pass in all of your data into LLMs and like do all of this. It's just easier to use another abstraction layer, which happens to be like a query engine or a rule engine that can then do this. And an example for a query engine is like openEHR AQL, the FHIR search parameters in some way. SQL, and again, we are looking at SQL on top of FHIR, SQL on top of these data substrates as well, SQL on top of OMOP, for example. And the rule engines. So these are engines that trigger clinical decision support. They trigger what is the next thing to do in case of like openEHR task planning, for example. FHIR SQL runs these rules and then figures out how good of a quality is maintained in a particular setting, right? And all of this kind of needs the query engine to run, and the query engine needs the ontology and the value sets and the information models to like really work cohesively. Although these two are the most, so the topper down the pyramid something is, the more likely that its role can be taken over by AI if the AI gets cheap enough and if it gets accurate enough. So today, if you ask me like what's the most comprehensive information model, like I would say just by going with the number of archetypes and the number of properly modeled data entities, I would say it's openEHR. And the most comprehensive ontology today is SNOMED. But that doesn't mean that we don't use the other things. They each have their own place, right? And the rule engine and the query language is kind of like out there. We still haven't figured it out. And I don't want to say with any dogma that like this is the best. It's just like my finding, and as a practitioner of health information IT, I find that certain things are more mature than the others. And when it comes to the query language and the rule engine, I would say like they're not there yet. We still need like more time and more effort needs to go in here before we can claim something that's fit for purpose, right? So what can we do with all this information that I've given you? So if you have unstructured data, it's really easy, in fact, with like an implementation guide or a profile or an openEHR template with the different fields to map it to the structured data substrate. Okay, this is very easy in the sense that it's possible today, and it's also pretty accurate with what we have today. So this is completely doable. So let's the other thing is you can convert natural language queries to openEHR AQL. You can convert it to FHIR search parameters. You can convert it to SQL. And you can also do this really well if you train certain models and if you prompt it enough. And the guidelines, so for example, when a particular clinical decision support needs to be triggered and when something needs to happen next, even this today, the natural language engines are good enough to convert this into something like openEHR GDL or FHIR CQL. Okay, so in essence, you can have exactly the kind of thing that you want. So you can work with unstructured data, you can work with natural language queries, you can work with natural language guidelines and get everything that you want, while at the same time keeping the cost of running all of this cheap, and by leveraging information models and ontologies to reduce the amount of ambiguity, right? So this seems like a good pattern for what we have today. Now, I'm not saying that this is the end, right? Like honestly, I don't know where this is going to go, but I just think it'll be it's not very smart to not pay heed to the progress that's happening right in front of our eyes. And just because we are practitioners of structured data and we think structured data is good, we should also go and look at the other fields and see how things are progressing there. So for example, it used to be the case that for computer vision, people used to handcraft certain things. Like you need to detect edges using this particular algorithm, and you need to detect eyes using this particular algorithm. And look at where we are today. Like we got rid of all of that, and like neural networks are able to do all of that just as well, or like much better, in fact. So I think with disruptive innovation, it's always the case that we don't see it coming and it catches us off guard. So to just reiterate, like there are possibilities of, for example, we are seeing, I've studied some papers which are doing this, which is, can we have learned embeddings and then label them as SNOMED-CT concepts or SNOMED-CT groups? So for example, let's learn all the medical concepts there are and like represent that in the embedding space and try to represent those embeddings, those learned representations as SNOMED-CT codes instead of just starting from scratch and representing SNOMED-CT codes. And definitely another thing that we definitely need to have is in the information models, we need to start making this more AI friendly. So we need to give it more examples. We need to give it more prompts on like, where can you use this? What is an example of an unstructured data point that can be converted to a structured information model? So if you want further study, like I would highly recommend this massive text embedding benchmark. So this is a paper by I think a lot of people, but mainly LinkedIn, Facebook, and so on. So they take these text models, the learned representation of embeddings, and they try to make it do things that it was never trained to do. And I think there is a lot to learn from this for practitioners of health IT and structured data. And I've also given this openEHR Netherlands AI talk where I talk about like the different techniques you can use to convert unstructured data to structured data, and natural language queries to AQL and so on. So you can take a look at that if you want to get into the more nitty-gritty details of like prompt engineering and what exactly true. But this talk was again, I just want to have you think in a different sort of way. It was not, I know maybe I have not given that much information to you on exactly what to do, but it makes sense to start thinking in terms of how is this going to change everything that we are doing. And it's always good to question, are we in the right path when we are together as a group rather than be alone while doing that. So that's it. If I have time for a demo, I can maybe show you like some unstructured data to structured data demos. But I think we may be running out of time as well. But you can always reach out to me on sidharth@medblocks.com. Any other questions? I think we'll keep that in the end, I guess. Yeah.
That's right. Thank you, Sidharth, for this interesting presentation.